Okay, guys, so let's just have a quick whiz through, having a look at a few things probability-wise, just getting ready for the mini quiz that's coming up. So the first thing, just to review the words that we have around describing probabilities, whether things are impossible or whether they are unlikely, there's an even chance, they're likely, or they're certain. So we know things that are certain are probability 1. Things that are evens got an even chance of happening, we've got probability half. Things that are impossible have probability 0. And something that's unlikely will be between 0 and a half. Something that's likely will be between a half and 1. So we can get questions like this, and these are sorts of things that might crop up on the little mini assessment that we'll be doing tomorrow, just to check how well you're all getting on with the work that we've been looking at. So we've got this spinner below. We're assuming it's a fair spinner, which means it's equally likely to land on any bit as any other bit. We've got 2 green sections, 1 blue and 1 red. And it says select any certain events for this spinner below. So what we're looking for, things that are certain, must definitely happen. It's most likely to land on green. Well, that's true, but it's not something that's certain. It's not certain that it's going to land on green, but it is true it's more likely to land on green. The spinner lands on a colour. Well, that's absolutely certain, isn't it? That's definitely going to happen, so that one's true. The spinner lands on green. No, that's not certain to happen. More likely than any other colours, yes. And the spinner lands on yellow. Well, there is no yellow, so it wasn't that one. So the one that was certain to happen was that the spinner lands on a colour. All right, let's have a look here. We're looking for a likely event in this question. So something that's got more than a half chance of happening, more than even chance of happening. You will grow a foot in height by tomorrow. I don't think that's going to be happening at all. You will brush your teeth in the morning. Okay, well, let's dot that for a minute. That is something that hopefully we'll be doing in the morning. The Earth will revolve around the sun. Is that likely? Well, it's definitely going to happen, isn't it? I think that's certain. So we can say that's not our likely one. Flipping a coin and getting heads. Well, there's an even chance of getting that, so it's not likely. It's not more than even. Actually, we would hope this is true. Most people do brush their teeth in the morning. Not everybody. Most people do. So that is a likely event. Okay, we've got some leaves here. Looking at the leaves, we're told that the probability of randomly selecting a brown leaf. So if we just said to someone, choose leaf 1, leaf 2 or leaf 3, give us a number, the probability that they'd randomly have chosen the brown leaf is 2 out of 3. The probability that they'd randomly choose the yellow leaf, well, there's 1 yellow leaf and there are 3 leaves altogether. So that should be 1 out of 3. Notice what we got here, 2 out of 3 and 1 out of 3. The numbers on the top add up to 3, don't they? Yeah, the 2 plus the 1 add up to 3. And 2/3 add 1/3 adds up to 1. You'll always get that. So if the probability of something happening is 2/3, the probability that it doesn't happen is 1/3. These probabilities add up to 1. Okay, so the probability of us getting a brown leaf we knew was 2/3. The probability of not getting a brown leaf, which here means getting yellow leaf, is 1 out of 3. 1 out of 3 to get the yellow leaf. Here we've got a spinner. Again, if we assume it's a fair spinner, what's the chance of spinning red as a fraction? So if we look at this one, we can see if we were to split it up a little bit, it might help us. And maybe if I didn't have a red pen, that would help me a little bit more as well. So let me change to a black pen. I can think about this spinner being split into quarters. Okay, so I've got 1, 2, 3 of those quarters are red and 1 is blue. So what's the chance of me spinning and getting a red section? It's going to be 3 out of the 4 sections altogether. 3 out of the 4. How many ways have we got of things working in our favour? There are 3 things that can work in our favour. We want red. How many quarters are there overall? How many places are there that pointer could land in? There are 4. 3 out of the 4 places the pointer could land are red, so it's 3/4. So here we've got some marbles. placed in a bag, and there are 16 of them that are blue, we're told. We're told that the probability of getting blue is 2/5. Okay, P blue equals 2/5 means the probability of blue there is 2/5. And we're asked how many marbles are in the bag. We know there are 16 blue. And we also know that that's a 2/5 chance. So would we be able to say what 1/5 of the marbles in the bag are as a number? 2/5 of the marbles in the bag, that's 16. That's what the 2/5 is. Yeah, 2/5 chance of getting blue. Well, that was 16. So 16 is 2/5 of the bag. 1/5 then must be 8, yeah? So if 1/5 of the bag is 8, what's the whole of the bag? What's the whole of the bag? The whole of the bag is 5/5. 5/5. So what have we done? We went from here to here, we divided by 2. From here to here, we're timesing by 5. We're making it 5 times bigger. To go to 2/5 to 1/5, we divide by 2. That's what we've done here. And then if we go from 1/5 to 5/5, or 1, we've got to times by 5 to work out how many there will be overall. So overall in the bag, there are 40 marbles. Okay, 40 is our answer. Let's just check. So we said the probability of getting blue was 2/5, but there are 16 out of the 40. Does that simplify to 2/5? Well, let's have a look. 2's will go in. Let me just do it simply to start with. So that would be 8 over 20. 2 into top and 2 into the bottom. 2 into the top and 2 into the bottom again. 4 out of 10. And 2 into the top and 2 into the bottom again. 2/5. That's what it said, wasn't it? So we know we've got the right answer. Okay, it works back that way. We've checked it back. Right, the next thing, just for us to have a quick look at, are this idea of sample spaces. So sample spaces where we get a diagram, a table, and we think about using that to help us work out some quite difficult probabilities. What do we have here? Well, probabilities would be more difficult without the diagram anyway. So we've got a spinner with the numbers 1, 3, 4, and 5 on it. 4, and we're assuming it's a fair spinner. We've got a second spinner split into 3 bits. It's got the numbers 5, 6, and 7 on it. And we spin both spinners, it says. Each spinner is spun once, and the numbers are added together to get a score. So if we ended up on a 1 and a 7, we'd say the score was 8. So it's asking us to complete the table and fill in all the possible scores. If I get a 1 on the first spinner and a 5 on the second spinner, getting the answer there, that's a 6. 5 and a 3, that would be an 8. 4 and a 5, that would be a 9. 5 and a 5 is a 10. 6 and a 1, 7. 6 and a 3, 9. 6 and a 4, 10. 6 and a 5, 11. 7 and a 1, 8. 7 and a 3, 10. 7 and a 4, 11. 7 and a 5, 12. So we've completed the table just by adding up the scores on both spinners. What's the probability of scoring an 8? Well, there's an 8 here, and there's an 8 here. There are 2 8s, but out of how many altogether? Well, here I've got a row with 4 red numbers, another row with 4 red numbers, another row with 4 red numbers. I've got 3 rows of 4 red numbers. There are 12 outcomes that are equally likely in my diagram. The 12 red numbers, 2 out of 12 then were 8. And 2 out of 12, simplify that down, divide the top by 2, divide the bottom by 2. The answer is a 6th. Okay, so that diagram, that sample space diagram, the table that we filled in, helps us to answer that question. It'd be quite difficult to answer that question without the table. Okay, without the table, it'd be quite difficult to answer that. But we've got a 1 in 6 chance of getting an 8. And then the final thing we've looked at with probability is where we have a tree diagram. Okay, so a tree diagram, and we've got a situation here with green and blue counters in a bag. So let's just remind ourselves, first of all, about how we start off with tree diagrams. So with a tree diagram, what's it tell us the situation is here? So a counter is taken from the container, and then it's replaced, and then we take another counter out. And it's only got green and blue in it. So we say to start off with, what's the chance of getting a green the first time? And what's the chance of getting a blue the first time? Chance of getting a green the first time? Okay, we're told that here in this question is 7/8. That's given to us. If we got a green the first time and then we've put it back, we could still get a green the second time, or we could get a blue the second time. And if we put a blue in, got a blue out the first time and put him back in, we could still get a green the second time, and we could still get a blue the second time. But there are some things missing on our tree diagram. We don't have all the probabilities written on the branch. If we have a 7/8 chance of getting a green to start with, then our chance of getting a blue to start with must have been 1/8. The same here. If we had a 7/8 chance of getting a green the first time, we have a 1/8 chance of getting a blue the second time. But because we've put the counters back in, if there was a 7/8 chance of getting green the first time, it must be the same the second time. We've still got the same number of green counters in there. And so we've still got the same probability for blue as well. 7/8 add 1/8, remember, makes 1. 7 add the 1 here gives me the 8 on the bottom. We'll always find this works out. When we add up the branches, they should add to give us 1. Okay, so we've filled in our tree diagram. What's the probability that we get counters that are different colors? All right, so I'm going to write on here, that's green and then green. This one was me getting a green and then a blue. This one was me getting a blue and then a green. This one was me getting a blue and a blue. I'm interested in getting counters that are different colors. So it must mean they can't be the same. Yeah, I can't get 2 greens and I can't get 2 blues. To work out the probabilities on a tree diagram, when you get to these outcomes at the end, there are 4 outcomes. They are not 4 equally likely outcomes. I can't say it's a quarter chance of getting here because there were 4 of them, and a quarter chance of getting here because there's 4 of them. All right, the probabilities are different. There were more greens in there than blues. We've got more chances of getting greens than blues. So it's not like heads and tails, where we could say this at the end, that it's a quarter chance of ending up at each one, because it's always a half, a half, a half, a half. Some of these are more likely, the greens are more likely to come out. So what we do with a tree diagram, we multiply along the branches that we've gone to get the probability at the end. So I say 7/8 times 1/8 will take me to that green, blue. 7/8 times by 1/8 would be the probability for that, because what I'm looking at, I'm using the 7/8 here and the 1/8 here, because that's the route that I've gone. I've gone there to there. Okay, 7/8 times 1/8 times in a fraction, you times across the top, 7 times across the bottom, 64. 8/8 is 64. And then we do the same for the blue-green, because that's also different color. Blue and then green. We trace that out. 1/8 times 7/8. It's just the same calculation, really, isn't it? The numbers are just written the opposite way around. So we're still going to get 7 out of 64. 1 times the 7, 8 times the 8. So we've got 7 out of 64 chances of ending up green-blue, 7 out of 64 chances of ending up blue-green. So overall, there are 14 chances out of 64. This is the 7, add the 7. What we've done there is add 7 out of 64 to 7 out of 64. Okay, add the probabilities up at the end of the branches. 7 out of 64 ways of getting green-blue, 7 out of 64 ways of getting blue-green. So there are 14 out of 64 ways of getting that all together. 14 out of 64 ways that come out to say they're a different color. What does that mean? Well, it means that 50 out of the 64 ways, okay, we would have got the same colour. That's actually really likely, isn't it? 50 out of 64. Really likely. Do remember as well, these can be simplified down. 14 over 64, we can divide that out and get 7 over 32, because 2 will go into the 14 and 2 will go into the 32. So 7 out of 32 chance of getting them different, but we had a 50 over 64 or a 25 over 32 chance of getting them the same. That's really pretty likely that they end up being the same. Okay, good job. So coming up in our next lesson, and the last little thing that we'll be doing during our lockdown lessons is just doing a mini check-in quiz, just so that you can see how well you understand this probability topic, and so that I can see how well you've got on with it as well. We can then just see how we take stock of that when we go back in the classroom, what we need to do just to sort of fill in any gaps and get everyone happy about this topic. So this will give you a good chance to see how well you're doing, and it will also give me a chance to see how well you're doing as well. Today, though, there's a practice exercise that's going to help you to prepare. And if you're in the Google Classroom, we're doing this not in EP this time. We've got some better questions for practice because we've used the EP questions in a different platform called Dr. Frost Maths. Okay. If you follow the link in the Google Classroom for this lesson, you just click on that link. Your account has already been set up for you. It will just ask you to create a password for it, or to link it to your school email, which you can do via Google, which means you don't have to remember another password. You can just use your school email account. And if you're logged into that in Google, it'll go straight through for you. Okay, so follow the link in Google Classroom, finish setting up your account. That's the link that's in there. Just click on that and it will take you through, takes you to our class in Dr. Frost Maths, takes you to your account. You just need to create a password. And then do the task that's going to appear for you. It's called probability review questions, and it's just going to give you a little bit of a practice of the stuff we've talked about today so that you feel a bit more confident, hopefully, a bit more comfortable about the questions you're going to get asked tomorrow in the mini check-in. All right, the mini check-in tomorrow, if you need to use things that you've written down to help you, any things you want to look at, that's all completely fine. It's an open book test, so you can look at whatever you like while you're doing it to help you do the questions. That's all fine. The key thing is that you can figure out how to do them. All right, so for today, so it's probability review questions. Click on that link to take you through to Dr. Frost. Do the questions, and then tomorrow there will be the detail in the lesson about the mini check-in quiz. Okay, let me know if you're not sure about any of the questions in the review. You want us to have a look at them, that's all fine. We can get it sorted. Any questions now? We'll take those now. Okay then, guys, good luck, and I will see you next time. Looking forward to seeing you in school again too.